Okay, so I'm just going to look at deriving the velocity formulas. Like we'll just do this one here. And we're just going to do it for simple harmonic motion, and we're going to do it from the acceleration. So you've got x double dot equals minus n squared x. Okay, so to actually go from acceleration to velocity, we need to replace x double dot with d with dx over half v squared. So you go d with dx over half v squared in place of the acceleration equals minus n squared x. And then when you integrate this on both sides with respect to x, you get a half v squared equals minus n squared x squared on 2 plus c. So then, because it's simple harmonic motion, we know at the endpoints v equals 0 when x equals a. Because if you think about it, x equals a when the velocity equals 0. That's the amplitude. And the gradient up there is 0. So that means that 0 equals minus n squared a squared on 2 plus c. So c equals n squared a squared on 2. So that means that you now have a half v squared equals minus n squared x squared on 2 plus n squared a squared on 2. The halves will cancel out, and you get v squared is n squared a squared minus n squared x squared, which is n squared a squared minus x squared as required. Okay, so now looking at a question where we actually find the max speed and the max acceleration. So we've got acceleration equals minus n squared x. So giving you that formula. They said to show this, so we've actually already done that, so we're going to leave that one. Now we want to get the max speed. Now the max speed occurs at the centre. So that's where x equals 0 in this motion, because the centre is at 0. So if you've got v squared equals n squared, a squared minus x squared. So it's n squared a squared minus 0 squared. So it's just n squared a squared. So the max speed, if we're talking about speed, we need the positive of this. So it's just na. If you want to get the max acceleration is at the endpoint. So you have a maximum acceleration here. So you just got to kind of remember V max is in the middle, A max is at the ends. V is 0 in the middle. V is 0 at the ends, and A is 0 in the middle, and V is 0 at the ends. Okay, so if you want the maximum acceleration, x double dot equals minus n squared x. So when x equals plus or minus a, so x double dot is plus or minus n squared a. That would be your maximum acceleration. Okay, so the next thing we're going to look is just using these formulas to find a few things. Now sometimes you notice in 2000, which is a long time ago, you guys weren't even born, we need to learn these formulas because you need to be able to quote them. So if you're not given, just assume the centre is at the origin. This one does say it is at the origin because it's just a shift. So wherever it is, it's still going to have the same max speed and things like that, and period. It's just shifted. So it tells you the amplitude is 3, but the period is 4 pi. So that means that 2 pi on n equals 4 pi. So 2 pi equals 4n pi. So if you divide by 4 pi, you can get n. N is equal to a half. So find its speed at point 0. So point 0 is at the centre. And we know at the centre is where you reach your max speed. So if you memorise this, it's na. If you don't, you just put in x equals 0 and v squared equals n squared, a squared minus 0 squared. So v squared equals n is a half, so it's a half squared times a squared, and a is equal to 3. So v, when you square it, that would be a half times 3, so it's 1.5 metres per second. Okay, so looking at this here then, a particle is moving in simple harmonic motion, so that means you can actually equate your formulas. And the max speed is 2. So the max speed we know is when x equals 0, so it's v squared equals na. So that means 2na equals 2. And the maximum acceleration, so that's going to be at the extremities. So the maximum acceleration will be like that, is 6 meters per second squared. So they've taken the positive one there. So because they've taken the positive and they're saying 6, then you're going to do it at x equals minus a. Otherwise it's going to be undefined. So basically, if you think about this, the acceleration is a max here and the acceleration is a max here. This is where the acceleration is negative because it's concave down, and this is where the acceleration is positive because it's concave up. So this is at minus a and this is at plus a. So that's why you would take it at minus a. So it's n squared a. So now we have two equations, two unknowns. If I get n squared a equals 6 and na equals 2, and I do 1 divided by 2, I'll get n squared a on na is 6 on 2. So I end up with n equals 3. Okay, so we have, if n equals 3, let's come back over here, 3 times a, then a would be 2 on 3. And n equals 3. Okay, so this is given the velocity, which is v squared equals this value here. And what we want to do is show that it's simple harmonic motion. So to show it's simple harmonic motion, we have to find the acceleration. In order to do that, we sub this into dv dx over half v squared. So it's dv dx over half times 108 plus 36x minus 9x squared. So that's going to be a half times, and I'm going to differentiate this, 0 plus 36 minus 18x. So that's going to be 18 minus 9x. So that means the acceleration is minus 9x minus 2. Okay, so therefore it is simple harmonic motion because the acceleration is the form of minus n squared x minus c. Alright, so now we're going to find the period of the motion. We're going to find the period and we want to find the amplitude. So the period I probably should have... okay, so from before, the acceleration is equal to this, which is minus n squared x minus 2. So you notice that n squared is 9, so n is 3. So the period is 2 pi on n, which is 2 pi on 3. The centre is x equals 2. Okay, so I've got the amplitude. I need to get the amplitude. To get the amplitude and the extremities, or the points that it oscillates between, you need to put in v equals 0 into this formula. So I'm going to keep the centre there. We know it's at 2, but it'll come out in this one anyway. If you put in v equals 0, then you're going to get your endpoints. So it's 108 plus 36x minus 9x squared. I'm going to divide by 9 because I can see, or just factorise out the 9. I can see there's a common factor of 9 there anyway, so you get x squared. So that means that you're going to get 9, and I'm going to take the minus 9 out because that's just going to make it like that. And minus 9, so it's going to be x minus 6x plus 2. So x is 6, x equals minus 2. So it oscillates between minus 2 and 6, and the centre is at 2. So that means that your amplitude must be 4. So what is the value of, for what values x does it reach its max speed? So remember, the max speed is in the middle. So that's at the centre of the motion. So that's for x equal 2. And the actual max speed is na. But you can, if you remember that, then you can just use na. And if you don't remember that, then you can find it by getting the max, putting the centre, and the centre is as x equals 2, and putting 2 into there, and you'll get it as well. Now, I just want to show you an alternate way of actually doing this. Like if you can get this thing here and you want to find information, you can actually put it into the form of n squared, a squared minus x minus c squared. Then you can read a whole lot of stuff off from this as well. So if you take the 9 out, you get 12 minus 4x minus x squared. And then 9, so you get 12 minus x squared plus 4x. And then looking at that, what you then get is 9, halve it, square it, add it. So you go square 4x plus 4. So you add 4. So it's 9, 16 minus x plus 2 squared. So looking at this here, n equals root 9, which is 3. A is equal to root 16, which is 4. And the centre, there must be a sign error. And yes, I can see the sign error because this here should have been a plus. So therefore that will make that a minus. So therefore that will make it a minus. So the centre is at x equals 2. And everything else is the same.